Well, hello everyone, and welcome to NYC Builds Bio virtual webinar in collaboration with Genetic Engineering and Biotechnology News and the Biodesign Challenge. The webinar is entitled The Biodesign Challenge, Growing the Future Pioneered in New York City. Thanks so much for joining us this afternoon. My name is Nancy Kelly, and I serve on the steering committee and as a founding member of NYC Builds Bio. I'd like to acknowledge the founding and corporate members of NYC Builds Bio who make this programming possible. I also want to thank Dan Greshkin, Executive Director at the Biodesign Challenge, for supporting this seminar. Today we're celebrating an organization that is very near and dear to my heart because I helped Dan to launch the Biodesign Challenge in 2016, and some of our members were early funders of Dan's efforts. Recently, we participated in the 2020 challenge, which Dan will tell us more about, that now includes design schools from all over the world. This webinar is part of an ongoing series of online events hosted by NYC Builds Bio. I want to call your attention to the September quarterly breakfast scheduled for September 17th. I guess it's a luncheon from 1 to 3 p.m. when the Dean of Albert Einstein College of Medicine and executives from Simone Healthcare will join us to discuss the exciting new life sciences developments that are contributing to a scientific and medical renaissance in a new Bronx, one of the largest developing life science subclusters in New York City. And please register for our flagship event, the 2020 Annual Life Science Real Estate Development Symposium, scheduled for October 23rd. We'll be announcing the agenda shortly, which is jam-packed with interesting speakers and highlights new developments for New York. Our media partner, Genetic Engineering and Biotechnology News, will be advertising this both nationally and internationally for the first time. If you weren't able to attend our past events, be sure to check out those programs on the NYC Builds Bio website, which features links to the videos. And stay tuned for the quarterly newsletter, which will be coming in September, highlighting lots of positive news for life science in New York City. But today, I want to introduce my good friend and colleague, Daniel Greshkin. Dan is founder and director of the Biodesign Challenge. He's also co-founder of GenSpace, a nonprofit community laboratory in Brooklyn dedicated to promoting citizen science and access to biotechnology. Dan has been a fellow at Data and Society, at the Woodrow Wilson International Center for Scholars, and an emerging leader in biosecurity at the UPMC Center of Health Security. As a journalist, he's reported on the intersection of biotechnology, culture, and business for publications including Bloomberg Businessweek, Fast Company, Scientific American, and Popular Science. Today we welcome not only Dan, but the two winning teams from the 2020 Biodesign Challenge and the founder of a startup, New York City Biotech, that was the winner of the 2016 competition. Lots of interesting stories here, and Dan will introduce them to you in his remarks. So thanks everyone for joining us today. Before we begin, I just wanted to cover a few administrative details. There's a program and a PowerPoint highlighting the hosts and speakers for the meeting. This will be posted on the NYC Builds Bio Plus website afterwards. The program's being recorded and will be distributed to all of the registrants from the meeting. If anyone's having technical difficulties accessing the Zoom room or other technical issues, please email info@nycbuildsbio.org or send a notice through the chat button at the bottom of your screen. Since most of you are participating in listen-only mode, please feel free to submit your questions via the Q&A button at the bottom of your screen, and we will open up for discussion and Q&A at the end of the program, and we'll address as many of your questions as we can. At the end of the meeting, we'll have a chance for smaller randomized groups to meet in separate rooms where you can all open your videos and microphones to talk to each other, and our speakers will join us there as well. You can stay as long as you like and share and get to know each other and share each other's stories. So now I'll open it up to Dan Greshkin, who will give some opening remarks on behalf of the Biodesign Challenge.
Thank you for the introduction, Nancy. I appreciate it. I'm really excited for today's conversation. Of course, thank you to NYC Builds Bio for inviting us to speak about the Biodesign Challenge. Before I begin, I should say that Biodesign Challenge owes a special thanks to the real estate community in New York City for being our earliest supporters when we got started. So a big thanks to JBB, Milrose, Hunter Roberts, and of course, Nancy, who has been a support all these last 5 years. I don't need to convince anyone that we're right now in a biological moment that is changing everything about human culture. I personally believe that even when we exit this pandemic, 21st century biotechnology will continue to affect culture. And this includes everything from the way that we view ourselves, to the way that we view each other, to the way that we view our environment. So we created Biodesign Challenge 5 years ago to anticipate those changes, critique them, and maybe even affect their outcomes. The program brings students from universities and high schools around the world together with artists, designers, and biologists to imagine, create, and critique the future of biotech. I like to say that we're fostering the first generation of biodesigners. Those are practitioners who are fluent in both the language of science and design. It's probably too simplistic to say that a scientist alone determines the course of a technology. Maybe that's true in medicine, but the truth is that, one, the largest market in the bioeconomy is not healthcare, but actually industrial applications. And two, the next applications in biotech will be in everything from architectural materials, fashion, food, beauty, to areas we don't even know exist yet. And these applications aren't going to come from scientists, but scientists working in collaboration with others. I think what we're building with the Biodesign Challenge is actually a new academic discipline, one that melds the technical knowledge of the scientific community with the creativity of the art and design communities. I'd say that the closest analogy for the future of biotech is maybe digital tech today. So how many of today's tech startups were founded by people who know how to assemble computers? Some maybe do, but do you need to know how RAM or an IO port connects to a motherboard to conceptualize an Airbnb or an Uber? You know, what makes an iPhone a better product than, let's say, a Palm Pilot isn't necessarily the technology, it's the design. And so where digital tech has led, biotech is following. Biotech is leaving the biology department. It's becoming accessible to the rest of us. I know this because 12 years ago, my friends and I built a lab in my apartment in Brooklyn to do genetic experiments in my home. And in fact, it helped launch the community biology movement. And out of that movement came Opentrons, I think a company that folks here know very well. Their founders have spoken on this stage before. They were started by a designer and an engineer who met in our community lab, GenSpace. And it was actually started as a design thesis project. And of course, now it's a major biotech employer in Brooklyn. So, you know, how many of you have seen a PCR machine in the shop at a design school? Well, I have, and I think it's actually going to be common. These tools are no longer the province of scientists. I think they're now the province of everyone. So we started the Biodesign Challenge in 2015 with 9 schools in the United States. That year, I literally knew every project because I visited every classroom. We held our summit at the Museum of Modern Art at a small theater, only 125 seats, where students came from around the country to present on stage and compete for our version of the Stanley Cup, which is called the Glass Microbe. Now, 4 years later, we filled MoMA's largest theater with 400 people. And this year, because of the pandemic, we held our summit online and 5,000 people tuned in worldwide. We're now in 12 countries on every continent save Antarctica. And we produce roughly 125 biodesigns a year. And our students have gone on to win every sort of award, from business startup competitions to international art and design awards. So I'm very, very proud to introduce our panelists today. These are designers who are alumni of the Biodesign Challenge, and they're here to share their ideas with all of us today. So I'm going to introduce them briefly, and then they'll talk about their projects and their backgrounds, and then we'll go into conversation. So first up, I'd like to thank Masa Banadaki and Emily Marquette. Both are MFA students of color and material design at College for Creative Studies in Detroit. Masa, Emily, and Wei Huang won the Glass Microbe at this year's BDC competition for their project, Zebra Glass. They're here with their instructor, Matthew Strong. We also have fashion designer Uyen Tran. Uyen won this year's Judges Recognition Award at BDC for her materials project, Tomtext. Congratulations, Uyen, by the way, for winning the grand prize at Textiles. That was just announced. Uyen is here with one of her instructors for the project, Harpreet Sareen. Harpreet is an assistant professor of interaction and media design at Parsons School of Design. He's also quite a designer in his own right, and I hope he'll talk about his work. And finally, we have Tessa Callahan, who's a designer who won the first year of the Biodesign Challenge with her teammates for a textiles project called Algae-Based. Algae-Based is now a venture-backed company. So as I said, the panelists are going to talk for a little bit about their projects. So take it away, Masa and Emily.
Hi, everyone. Thank you for having us today. My name is Emily Marquette, and my teammate Masa and I, we are the team that has created Zebra Glass along with our other partner, Viva, who couldn't be here today. But my background is in interior design and right now studying color and material design at CCS.
Hi everyone, my name is Mahsa Banadeki and now I'm studying color material design, and my background is in jewelry making, designing and painting. And here we're going to talk about the project today. Thanks.
So under the instruction of Matthew Strong, we've come up with the Zebra Glass. And living in the Great Lakes region, we've focused on the invasion of zebra mussels within the Great Lakes. So our project discusses the need for zebra mussels to be mitigated, but not necessarily eradicated. So the purpose was to collect zebra mussels in order to remove stigma, create demand, and contribute to the conservation of native ecosystems. So rather than seeing zebra and quagga mussels as a threat to the ecosystem, we've decided as color material designers to view them as a naturally abundant material in our region. So through this lens of materiality, we're choosing to establish local connections and to create identity within the zebra mussels for our region. So throughout our project, we've created soda lime glass from zebra mussels. And we've chosen glass specifically because we began with looking at different problems within our region and noticed invasive species and zebra mussels. And within looking at the compound of the zebra mussel shells that are the most problematic on beaches and to infrastructure, we've noticed their high content of calcium carbonate, and then established a connection between that and glass making. So through that, our our idea for our prototype was to create the glass. And then from there, we've decided to look at color within the material and looking at bioaccumulants from each lake. And we're forecasting that the color of the glass will be different from each lake based on its native ecosystem. So the first lake that we began with was Lake Michigan. And our prototype for that was a beautiful cobalt blue color because of the ecosystem there.
And we are still working on the project, and we are hoping to continue working on the project next semester. So it's a to be continued project.
Yep, we plan to, in our future steps, plan to collect zebra and quagga mussels from each of the Great Lakes to establish more of a materials sample to see if our theory remains true from each of the Great Lakes based on our first prototype.
Yeah, and I'll just step in just from the instructor standpoint. Thank you so much for having us, by the way, Nancy. One of the most important aspects, I think, of the work definitely was the collaboration that we sought out. So we collaborated with scientists and policymakers from across the sort of relevant spectrum of people who, had some impact or interest or scientific background in invasive species and zebra and quagga mussels, not to mention the chemistry of glass making, and that lent a much more sort of robust, I think, face to the project. But it also really emphasized the collaborative nature of what biodesign is. Dan had mentioned before that, where do the sort of culture changing products come from? And, mentioned Airbnb or Apple. Steve Jobs was not a coder, as far as I know. And so I think one of the most important things about this sort of emerging area of design is the collaborative nature of it, that scientists and designers can use aspects of the practice that don't necessarily overlap to create additional value and create these sort of innovative approaches to science and design.
Can you describe just a little bit about what you actually had to create for the Biodesign Challenge? And I just want to remind everyone that is viewing today that the video about the project is on the NYC Builds Bio website and was also on the invites to this afternoon's webinar. So I would encourage you to look at that because it shows you the prototype, and you can get a good idea of what the project was actually about.
Yeah, Emily Massa, do you want to take that?
Yeah, so for our project, as designers, we've thought of a way to use biology and think of it in a different way. So that was our first step, was the narrative. And then for our process, we've established a set of rules that we've followed. And then we've designed a kiln program for which the glass would be fired, and then creating the glass. So we did do a lot of collaboration with, for example, glass departments or the Department of Natural Resources to see what was appropriate in the transport of invasive species. So for the project itself, we designed the process and then as well as the glass.
Thank you, all three of you. Uyen and Harpreet, would you like to talk about your project?
Yes, so it's so nice to meet you all today, and thank you for having us here today. So I'm Uyên, and I'm a Vietnamese, and I'm currently a textile designer and fashion designer here in New York. So I worked in the fashion industry for a few years before jumping back into the MFA textile in fashion, and yeah, and hybrid.
Hi, everyone. As Dan introduced, I am currently a faculty at Parsons, and my research and design work specifically focuses on moving conventional devices, stuff like mouse, keyboard, screen, and silicon-based devices to using nature itself for interaction. And in the recent few years, I've focused on replacing notions of human-centeredness in design to embracing larger picture of designing with and for nature. And some of the recent examples of these works include bionic plants, plants that have electronics growing inside them, or plants with nanosensors inside them that can monitor quality of water, or robots that are driven with the chemical signals of plants. I mean, the biodesign challenge for me was, one of the first teaching opportunities. So I'm excited to talk about it. But Yuyan was one of the students in the class, and she was, judged as the judges award winner for her project. So I'm excited to learn here how the developments are going for that project as well.
Yeah, it's really my pleasure to work with hybrid, through the whole biodesign challenge course and through the difficult time. So yeah, I developing a Tomtest biomaterial that is created from cell-free food waste and coffee ground waste with an arm to work as the sustainable alternative instead of false leather and animal leather. So Tomtest can provide designer creative freedoms with less material constraint on science scaling while minimize the environmental impact. So it is 100% compostable and natural biodegradable. I want to talk a little bit about what is this coming from, because I grew up in Da Nang, Vietnam, where leather textile were predominantly manufactured. So leather, as you know, is widely used in many applications across the industry. So, but people in my hometown or people around the world is suffering from the leather factory pollution. And dig deep in about researching what resource that I have. Obviously, like in Vietnam, seafood and coffee ground waste is widely available. And sadly, it's like most of them end up in landfill, and it generated like tons and tons of CO2. So in sourcing my material, I contacted with the small manufacturer in Vietnam who gather seafood waste in the market, factory, and restaurant, and use that to extract chitin and chitosan. And then I just asked my friends and my family to try to buy a small portion of different chitosan type that they have. So on top of that, I, gather all the coffee ground in my kitchen, or a food waste, or whatever that I can find to insert in my process. So the end, I think that the world is running out of raw material, that I hope Tomtest can be a small movement to generate the momentum and help people to understand the problem and contribute that we can make a change together. Yeah.
So I want to add, beyond the fact that Tomtest is a resilient biomaterial, Uyan is a prime example of a resilient student who converted her own apartment into kind of a biolab to synthesize these biomaterials, and also is a very prime example of how, you don't need to view biology as something that necessarily has to happen in a lab, but also not necessarily has to happen through a biologist. Uyan is a fashion designer who's been in New York operating as a fashion designer for a long time, but has worked with biology to create these materials that are exciting innovations now.
Excellent. Thank you both. That's wonderful. Tessa, why don't you close out the introduction section, and then we'll get into questions.
Great. Yeah. Thank you so much for having me here. So yeah, as Dan mentioned, I'm one of the co-founders of Algae-Based, And, we started this idea, myself and my two other co-founders, in the first Biodesign Challenge in 2016, which feels like just yesterday and also eons ago, but with Erin Nesser and Alexandra Goshevsky. So what we do is we are creating fibers and yarns for use in textiles within the fashion industry and, a variety of other industries that are derived from a seaweed called kelp, in order to transform and revolutionize one of the most polluting industries on the planet, something that we don't, necessarily recognize, or, even I didn't recognize until I was really confronted with how polluting it really was as an industry, and how a majority of it really does end up in landfills, which is, probably about 60% every year of just the clothes that are produced are sent to landfills before they even reach the shelves. And so we have a lot of issues that are more than just consumer nature or, the retail based. It's really the materials that they're made out of are preventing a circular economy, and are really driving this, mass devastation that we're seeing on a global level. And so, what we did when we were, began thinking about this idea was consider, how as designers, myself coming from a knitwear background, how can we use the skills that we have in order to rethink the systems that we're working in? And so for us, it was really important to not reinvent any of the supply chains. I mean, everything that we're dealing with.
This is Matt there. Hello? Yeah, you call me back. The name's Charlene Kuo about my road improving.
Charlene, can you mute yourself? I'm sorry about that, Tessa. Go ahead.
No, that's totally fine. Hope everything's okay, Charlene. Yeah, so what we're doing is, really looking at the supply chains that already exist, because we need change to happen yesterday. So how do we go as fast and as impactful as we can? And so, for us, we're looking at the pre-existing manufacturing on all ends. So from the kelp and the, harvesting and processing to get these biopolymers, taking what these experts are doing, taking experts in fiber manufacturing, experts in chemistry and engineering, and utilizing these systems so that we can basically plug in every step of the way, except just replace all the toxins with things that are naturally derived and that allow the material to be compostable. And so, with this idea, we really were able to explore it within the Biodesign Challenge, but then following that, we're able to connect and, eventually hire some absolute rock stars in science and biology and chemistry, and in a variety of fields in order for us to really make this idea and turn it into, a reality. And so now we're a team of 12 in the Brooklyn Army Terminal, which is really exciting for us. And I think, really, one of the most exciting things for me is being able to collaborate with so many people in different fields and in different industries where through that collaboration, we can actually start to talk about change in a more meaningful way. So I'm excited to have this conversation and hopefully, can connect with whoever is interested afterward, because I think that's really how we're all going to make a bigger impact, is by, talking with each other. So thanks so much for having me here.
Thanks, Tessa. We appreciate it. Let's start with a simple question, which is, none of you are biologists, and yet you decided to join this course and go through this competition. What was it originally that intrigued you, that interested you in going forward with it? What drew you to what drew you to biology in the first place?
I can start. I think for me, I kind of saw design and my skill set as not being explored to the fullest, and being able to use design as a means of communication, and how I was really kind of questioning myself in terms of how can I explore my own skills and make them as applicable as possible. And biology to me was always something that I struggled with. We were worst enemies for my whole life. Up until the Biodesign Challenge itself, when I realized this is something that's accessible, and as long as we can communicate on the same plane, I think, there's a lot more strategies that we can come up with. So it kind of was like genuinely a challenge, but really inspiring.
Leanne?
Yeah, so for me, it's like before the Biodesign Challenge is always a imagination. And after that, it is the reality for me. So before, as the fashion designer and textile designer, I always imagined like, what if we didn't have to extract more of our blended resources, but instead of like starting growing material within our country and community. And I imagine what if we treat our waste today could be our new for tomorrow material, and systematically become the new material that I can use. So within the Biodesign Challenge, for me right now, I think it is come back to the community where the people across the industry that come together and have the same voice and to make this thing happen. So yeah.
Sally, welcome. Sally, by the way, is the Dean of CSS and
No, I'm not. I'm the chair.
I'm sorry, the chair, pardon.
I can introduce you to the dean if you'd like.
You brought the program to the school. I wonder what drew you to Biodesign Challenge, and why was it important to you?
Thank you. Can you hear me, by the way?
Yes.
Good. Honestly, it was students asking. I'm going to be fully transparent with you and say that we had a student leave our program to go to another school. And I'm still in contact with that student, and we've retained a really good conversation. And one of our students, in the same time frame that this student left, after 1 year of the program, had done a capstone project on a SCOBY project. And he was extremely innovative and, well, let's say resourceful. We don't have a laboratory here at CCS. We have, limited. We have beautiful studios, but we have limited. We're a small school, so he sort of took himself up to Target, and I think bought about 20 to 30 Tupperware containers, and grew this SCOBY as sort of a large-scale operation, including using electric blankets to keep the temperature up. He actually got moved to an area that was being built out by a building project because the students were complaining about the smell. I mean, it was very, very low tech. And some students actually kind of looked at him and sort of thought it was all a bit, naive. And there were actually sort of, people who's not mocked, but kind of just didn't really get their head around the fact that he was doing his best with very little to just innovate and disrupt, actually. And so he pursued that and actually, created quite a bit of material, and then his capstone project ended and he graduated, and that was history. But so after that experience, students started, it was really that student's sort of SCOBY initiative that sort of perked the interest of other students. And the student who decided to go to another school sort of cited reasons like our facilities and things like that as being one of the rationale. And I think, in all fairness, the lure of Europe as well was certainly a big pull. Why not? Yeah, I would go too, I think, if I had the opportunity to go back to school in London right now. But anyway, so long story short, the students started asking, and I think, students can share with you, I was quite petrified, actually. I was planning on it being a beta version. We were just going to do it so we could learn how the process worked. We were going to use the opportunity to sort of practice how this competition worked and keep a low profile. And then, you know, thanks to Emily, Massa, and Viva, that didn't happen. So, you know, under Matthew's, you know, guidance and enthusiasm, and culturally we came at this from two very different sort of perspectives. You know, Matthew was extremely bold and knew that this was going to have a successful outcome, and I was being very British about it. Perhaps that was the old British way. I'm not sure how it is there now. Haven't lived there for a long time, but you know, it was kind of, don't overstate it. You know, we're just gonna, we're gonna be fine. We're okay. We're not. Let's assume these sort of cultural traits of ours. So I think, you know, thank goodness, you know, you didn't have me running it. So I think actually Emily and Asa and Viva's achievements would have shone regardless. And, you know, my skills are kind of getting somebody, it's probably not something I should say publicly, but, you know, people said to me once, Sally, you always get what you want. You know, if you have a goal, you usually manage to sort of get there. And we'd been sort of told that, you know, we couldn't possibly make this, you know, but I think we did actually sort of work through the steps in this sort of COVID remote teaching and learning situation we were all in, because we were not allowed on campus at all in April, May. And so we took a sort of ask to the president and the head of security, and we just worked through the paces of getting a team back on campus to do this. So, but yeah, to answer your question, definitely student driven. I mean, they were just felt like we couldn't not, and a program with materials in our title, I just felt like we couldn't not do it. Time had run out, so.
Great, thank you, Sally. Harpreet, I wanted to ask a similar question to you. You know, your background is in working with electronics and plants, going back to MIT Media Lab, and then coming to Parsons. I just wanted to, you know, you came from a very technical school. What was it like to come to a design school, and what was the experience of teaching essentially the intersection of biology and design to this new cohort of students?
That's an excellent question. I mean, my background has been in electronics, and, you know, electronics, to what you were mentioning in the very beginning of this call, we are going to hit the limit of Moore's law in about 5 years. And Moore's law, you know, everyone here on the call might know, but every 3 years you get a doubling of the chip number on the ICs, and that's been driving our digital revolution. In 5 years, that's almost over, and we're not ready. You know, but it is not going to be completely over, because, you know, something else is taking over. And I've been thinking about it a lot, and that the answer to me was biology, to find organic materials that are suitable alternatives to electronics, right? And as an interaction designer, my work was to use electronics to create new interactions out of the computer, out of the screen. But I went a little bit farther than that to figure out, you know, what are the organic materials of the future that are going to drive such revolution, and what are the possibilities of such interactions. And if you look at it, you know, our traditional approach has been to develop all these interactive devices artificially from the ground up. But that's because that's what we know how to do from the Industrial Revolution, right? It's a very old process of how to harness silicon, and that's what we are good at. However, recent controls of biology have taught us, you know, such a good analogy between natural capabilities that exist in nature versus what we're trying to do with electronics. And to me, you know, the plant's world was very, very similar to electronics. You know, we propagate signals in artificial circuits. Plants do that. Plants actually even go beyond that, because plants are self-repairing, self-powering, self-growing. This is the kind of electronics that we actually want in our environment, and, you know, we haven't been able to get there. So to me, plants are actually an inspiration for the best kind of electronics that we want, and that's where I started. So the overarching reasons were this: you know, plants are already these interaction devices occurring in nature. They change their color, orientation, moisture, position of flowers, leaves, and whatnot. And these are the interactions that we are used to. We're not used to sitting in front of the screen. So how do we reorient biology to do some of these digital interactions, but with plants? And by doing that, how do we discover the future organic materials, right? So for a long time, we have understood these sensing mechanisms or electrochemical signals inside the plants. But the way I've been looking at my work is to envision an additional digital interaction inside the plants to compose these biodigital interactions through them. And that has given us the capacity to expand the definitions of materials that we work with. For example, a biodegradable electronics that grows inside the stem of a plant is probably not how the future is going to look like, but that thought experiment has given us a biodegradable alternative to silicon, right? And that to me is very exciting, because that doesn't point to not just an exciting innovation for now, but probably 5 years down the line, where we are going to be using such techniques, again, when the Moore's law wall hits. So I've been practicing all of this, again, from a very designer standpoint, but again, using the background that I have in technical engineering. And I think all of the people on this call have already mentioned biology as a tool is important to remember. While it may seem like we are making isolated progress out of nowhere and our synthetic materials are just growing and fabricating, it is only because we are understanding our nature better. And the more we understand nature, the better we become in our artificial methods. So as we move from industrial methods to modern biological methods, our prevalent methods of manufacturing, architecture, interaction are still deep in the Industrial Revolution era. And in about 5 years, that's going to change. One of the things that I just remembered, from the beginning of the call as well, of how biology could be very applicable to different fields. Let's say the Tokyo subway example comes to mind, where people use slime mold to figure out what is the optimal placement of subway stations in an urban city, right? A biologist or a transportation person would not have been able to think about that alone, but bringing them together, that was one of the prime examples of how fields can come together as well. And that's what I've been doing in my research and in my teaching as well.
That's actually a perfect segue to Matthew. As someone who's been working with the built environment as an architect, a furniture designer, what was it like incorporating biology, biotechnology into your teaching?
Yeah, thank you for that. So my background ranges from, my undergraduate degree was in civil engineering. So I studied engineering materials and structural engineering. I also have certificates in craft. I had a minor in English literature, and now I'm in architecture. So in terms of the overall competition, the notion of combining science, material science, craft, and a design lens combined with sort of a focus on narrative was a really good fit for my skill set. But yeah, in the architecture world, we're confronting this too. I think one of the largest kind of disconnects or possibilities for a kind of interruption of the sort of prevailing norms in the building trades is the sort of disjunction between energy conservation and material conservation. We build buildings with highly sophisticated layers of insulation and barriers, vapor barriers, air barriers, and these laminated systems that go way above and beyond defying sort of McDonough's injunction to avoid the monstrous hybrids of, laminating not only just organic and technological materials together, but just materials together in general that make them impossible to recuperate. By doing that, we assure that those materials will be discarded, and we make it impossible to participate in a cyclical technosphere, a material stream. But by doing that, we're able to appreciate extremely efficient systems in our buildings, make it easier for us to use less energy to heat and cool them. And we're able to realize savings in terms of the carbon that we use. And so there is a net benefit to the overall environment on a global scale, but the material systems sort of don't align with that. Now on the interiors, the way that we sort of approach that is that we're using low VOC, organic, natural materials, because we realize that those things not only are good for the environment, and but they're also good for human health. And so there's a kind of disconnect there, and I see that as one of the real areas of opportunity for biodesign to come in and solve that. It's a massive problem, making our buildings more cyclical, while at the same time making sort of engaging in a kind of a biological transformation of the systems that we use. In terms of teaching, I think one of the things for me is that the problems that we're facing, and Harpreet was sort of speaking to Moore's law and the sort of larger notions of the systems that we're all caught up in, particularly with global warming and the climate crisis that we're in, a lot that was getting a lot of news before maybe 5 months ago, when the news cycle transitioned abruptly to another different sort of biological challenge that we're all facing. But I think as designers, one of the things that can happen is, one, you can start producing more products, which in the end is not beneficial to the problem. Or two, you can recognize that, again, this is a systemic problem. It's a problem that we need to reach outside of our areas of speciality and collaborate with large groups of people who are all sort of working on that problem, and come to solutions that are larger than just what we sort of are capable of within the design world. And so that, for me, focusing on invasive species and realizing that there's a lot of sort of inefficiencies potentially and waste, and a lot of opportunity that could come from being able to, in a systemic way, conserve environments by creating markets for invasive species materials, and that being an untapped sustainable material stream. That was really, really fascinating and interesting. And then it was really just about connecting to all the people who, had interest or were working in that area.
Great. I wanted to, I think what we're seeing is that there's an ethos built into a lot of these projects, many of which have a lot to do with trying to find sustainable alternatives to what we currently have available. I wanted to move the conversation back to fashion and textiles, Uyen and Tessa. One, because I think it's so much a part of New York's history and culture. And two, because, fashion is one of the top 2 most polluting industries in the world. What is the future of fashion? What should we be expecting? And is that a question? Maybe that's just too much to ask, Tess, but take a shot.
Yeah, so, I, throughout my experience working in fashion industry, I witnessed change from within my team. But I would have to admit that is a really slow change, especially I saw all the tremendous amount of textile pollution for example, high-end fashion, we trash and we incinerate it and we burn everything as fuel, our assemble to cancel style, with most of them, making from 60% of polyester, including faux leather made from PVC. So the thing is, it's not safe to burn as fuel because it's leaked out toxic chemical and it's called cancer and other health problem to the worker and the community. And also in fashion, we try to make an effort to recycle polyester or plastic bottle inserted back into the yarn. But it's controversial because, like, think about the microfiber that is when you wash your clothes, the microfiber that is leading to the ocean, and then it end up into the fish, and then we are the one who consume it. So I know that everyone is making effort to change this and rethink about the system, and that's why when people asking me about the role of biotech play in fashion industry, that I think it has to do with everything. It is about the material to the political aspect. So what I observe is that bioculture is play a tremendous effort and role by shifting the strategy within the certain institution culture that can create action in a lot of way. And you know, like the good news is like the customer mindset is changing too, and people is pays attention to you know, the whole story of the product that they buy, like apparel specific. The whole life cycle of the product was made from, it is fair trade, it is like, you know, treat the worker is in good environment. So yeah, I think it have to do with everything.
Tessa, I just wanted to follow up. I mean, you've been building your startup now for the last 5 years. Have you seen changes in the industry's perspective on, one, sustainability, but two, the role of biotechnology in fashion?
Yeah, I mean, I think it's been really fascinating to watch because, you know, I've definitely seen that shift of something that, you know, I think you've always kind of had, you know, those few companies that are the innovators, that are the leaders in this industry, but it's kind of becoming much more of a mainstream mentality and ambition, where you have these massive companies that, yes, they are not necessarily still making all of the right decisions, but not only do they have teams dedicated to finding better solutions, you can see it throughout their products. And so it's really becoming something that, you know, is no longer niche, and I don't think can ever possibly be, because not only, you know, as a world itself, but I think consumers are really demanding change, and they are starting to look at the labels, and they're starting to look at the impact. And you can see that. I mean, there was like a recent study talking about millennials and Gen Z, and I won't say the exact number, but is over a majority of them are willing to spend more on products that are sustainable and traceable than those that aren't. And so the companies that aren't willing to address this massive need in many factors aren't going to survive. And so I think they're starting to change, not necessarily always for a want for change, but a necessity.
Great, thank you, Tessa. Nancy, shall we open it up to questions, or do you have a question you'd like to throw to our panelists?
Yeah, so to the audience, we do not have any questions yet in the chat box, so it would be really great if you submitted your questions now so we can get you into the conversation. And it was really interesting to hear Sally talk about, you know, the changes in her school as a result of student demand for these kinds of activities. And, you know, I mean, Tessa, I know that you were one of the first teams at Fashion Institute of Technology, and they later built labs into their facilities, right, there? And so, Sally, is that something that you're thinking about? And does this, you know, kind of portend a real shift in how we train our designers?
I hope so, Nancy. Yes, I think that certainly we have the support of our leadership. And, you know, the thing so facilities are definitely one thing that's certainly important. I mean, I think that what the Biodesign Challenge has done, and a lot of the people that are participating in their own initiatives and lines of inquiry, you know, globally, is make science, and I think somebody else, Tessa perhaps mentioned this earlier, it's made it feel accessible, you know, made it feel like I can do that, I can achieve that, if I can participate in this research, and I won't be the design student who's kind of made to feel like the idiot, you know, in the corner, not knowing what they're doing. But I think, so yes, we don't have it yet. I mean, I think also we sort of operate a little bit like we're kind of disruptors, you know, we improvise, we make do, we find friends. You know, with this project, we have really good facilities in our craft and materials department, so we sort of walked over there and did it there. I think forward thinking and our mission and vision for sort of seeing how we lean in the future, you know, my experience is that whether you're pursuing your own startup business and your own initiative to kickstart something independently, or whether you're going to go and work for a big brand, even the brands, and I would include people like Nike and General Motors and Ford in that group, they actually don't want to see the projects that we teach them where they do the same type of work that they'll be doing when they go to those jobs. They want to see the thinking. They want to see the line of inquiry, more what might be thought of as the academic, inquisitive research. So even if you're going to end up in a job where you're doing perhaps things in an applied lane, the interest from a recruiter is to see you work independently through a line of investigation. And so I think we have a good series of sort of testament to that to make a case for building out our programming in these areas. And, you know, education is competitive too. We all know that. I mean, you've got to keep up, right? You can't ignore what other schools are doing and how the industry is moving. And it is really hard. I'm so impressed with the projects and those individuals who are doing things independently. That for me is just incredible. And not everybody has to go and work for a salary. You know, it's possible to do things independently. But if I can just add one more thing, and perhaps Matthew will sort of, Matthew and I went to visit a really wonderful team at the University of Windsor, which, as you know, is just across the river here, but well, when we could go across the river to Canada. And we were talking about this project that our student had done with SCOBY, and they said, you know, what were your protocols for sterilization? And we sort of got in the car and drove home and kind of went, you know, what sterilization, you know? I think, you know, I mean, everybody there was wearing white coat and, you know, 3 layers of PPE that before we needed to wear 3 layers of PPE. And, you know, we were just sort of, we felt a bit kind of like, oh, were we supposed to sterilize something, you know? I mean, and I think that's what's really healthy about bringing designers to a conversation about science, because we don't know the barriers. You know, we're quite happy to sort of break rules. You know, so now we've done something that perhaps, you know, we had a process, definitely had an organized process and methodology, but now we're in the phase of, you know, returning to that with the students to, you know, do it again, repeat the process, change some things so that we are checking our processes. And I don't know if we need to sterilize things or not, but we'll find out, I guess.
So, you know, so I think there's a difference between kitchen science, which which is often how you get started. And then when the projects get more sophisticated or you're working with much larger amounts, these things matter a lot more. You know, I actually wanted to throw that same question to you, Harpreet, because, you know, Parsons has found a way to partner the design strategies department with the biolab on campus. And, you know, I've been watching that occur over the last 3 years on campus, and it seemed to be really fruitful. Can you talk a little bit about it?
Yeah, so you know, as with many other speakers have said, biodesign, by its very nature, is just fusion of disciplines. And so when you walk into a class, especially at Parsons, you know, many students come from diverse backgrounds such as fashion design or electronics, architecture, anthropology, film, even environmental policy. We have had those students in our biodesign class. So many of these students are looking at using biology as a tool and are not really looking for, you know, a science course per se. And I think having a biolab in a design school makes it very unique in that aspect, because you know, many of our instructors are also thinking about a very similar way, the way students want to think about it. So the School of Design Strategies, even the School of Art, Media and Technology, where I am based at, are now looking at opportunities to collaborate with the interdisciplinary science lab that we have inside Parsons. But we are also looking to expand and, you know, kind of find more opportunities to have um, small scale grow labs or small scale bio labs at the university, where we can equip the students to do larger scale of work beyond the classwork as well, so that they can carry out their independent practice. And looking at the biodesign challenge has given the opportunity to evaluate that, and how strongly we want to vouch for that as well.
So Dan, we have one question from the audience, and you might want to talk a little bit about your experience in interfacing with some of the, you know, the industry giants. He says, what does the adoption curve look like for using the materials in different ways? Are there case study examples of how it can be successful? And maybe you can talk a little bit, I don't know if Stella McCartney or some of the other designers that you've worked with are actually applying these techniques in their work.
For sure. So I think I can start this answer, and then I think Tessa probably can finish this one. What we're seeing, at least from the major manufacturers of apparel, including folks like Kering or Stella McCartney, is that they're actively looking for alternative materials. Now, alternatives to some animal products, certainly alternatives to plastic-based products. We've now seen over the last almost decade a real search among biotechnology companies for alternative materials. I want to point out the folks who are working with mycelium, so actually fungus, to make alternatives to leather, or those who are actually going into the lab and making a spider silk alternative actually grown in bacteria and yeast. We're starting to see the first products from these really cutting edge scientific explorations. I think we're still a couple of years away, but the fact is that we're seeing North Face and the Kerings and the Stella McCartneys start to experiment with these materials. And in some ways, they're not just better because, or even Adidas, in some cases, they're not just better because they're environmental, but they actually perform better as well, which is really interesting and exciting. Tessa, what have you seen in that regard?
Yeah. I mean, I think, you know, there's so many interesting points to make here, but something that I do want to point out that's both a challenge and an opportunity is that this is entirely new territory. And so, you know, there aren't really any case studies because this is a new way of operating in so many ways and forms. And so, you know, for us, I think, you know, Dan, you're bringing up a good point. We have seen things really trickling in from, you know, like a mainstream, all of these massive companies adopting as much as they can and as fast as they can. I think in terms of a really great success story is Bloom, who are creating algae-based foams for footwear. And they started off, you know, they were way ahead of the curve 10 or 15 years ago, starting to do this. And actually, you know, didn't start as a footwear company, you know, started in a different area, but have then kind of branched out, seen this massive opportunity, and are now actually, you know, I think Adidas sold like 1 million pairs or something like that of their material. Again, I'm very bad at numbers, so please don't quote me on that. But they're really selling, you know, massive amounts in a lot of the footwear that we're using without even calling it out, really, because they're just replaceable with, you know, your typical EVAs. And so I think that, you know, for us, we're really seeing, you know, a mass amount of interest just in anything that's changed and that's different. And I think that that's really only going to be increasing. So I think, you know, the Bolts and the Modern Meadows and et cetera, Bloom are really going to be, hopefully us, are going to be, you know, really, really leading the way into this new way of operating in our supply chains, in our consumer products.
Right. I mean, I think that folks have to understand, you know, there are lots of steps to the process of bringing a new material to the public. It's not just, you know, the years that go into the work in the lab to get it to be the touch and the feel and the, you know, the structure that you're looking for. But then there's figuring out the entire production process, manufacturing process. What does it go into? I mean, there are lots and lots of questions about basically creating an entire supply chain that could go to, you know, go on shelves around the world. It's a, you know, unfortunately, it's not like releasing a new app that can instantly be uploaded to your phone. We're talking about a massive industrial change that takes a lot more time, and works on the scale of, you know, 5 years, 10 years, even decades for it to become a common item in your wardrobe. And so we're seeing that certainly happen now. You know, when will you be wearing your, you know, your spider silk suit? Or, you know, that's a good question. I think we're on the cusp of this. And so now is a good time to be watching this. Now is actually a good time to be investing in this, because I think once we make that switch, there's no going back.
Yeah, so I wanted to just thank you, Tessa, for mentioning those companies. And for those of you who don't know, Modern Meadow is a company that actually was founded and formed in New York City and was in Brooklyn for quite some time before they moved to New Jersey to set up a manufacturing operation there. And they actually moved out of New York because they couldn't find the facilities they needed to manufacture their product. But they're actively in discussions with designers from all over the world who are very interested in replacing their leather in their designs with Modern Meadows product, which is a laboratory-based material that mimics leather but is made in the lab and doesn't use animals. So that's kind of interesting. And what is the name of the company, Dan? The spider silk company?
There are actually 3 now. Bolt is the one here in California.
Bolt, yeah. Yeah.
But there's also Spiber. There's another one in Germany, AO Silk, and a handful on the way.
Right. So one last question before we get put into our chat rooms. From one of the people on the call, I would like to know about the winners. Where will they go from here with that biomaterial job? I mean, do they have some plan for moving forward?
Yeah, I would love to hear. What are your next steps? Ian, you have an exciting story to share.
Yeah, it is a lot of overwhelming for me, like and my journey is just about to start, you know, like after the Biodesign challenge, it's opened a lot of opportunity for me to step in and getting in more serious conversation with the people in the industry. And yeah, with Comtest, like we are still in R&D phase, and our priority right now is to develop a material that fits in the need of the market, and then still continue study the whole system. And what the method that of production that it needs to take place to work efficiency, and at the same time lower the environmental impact. One example that I kind of like learn right now is, learning from the existing brand and new business are bringing, the production to the retail space and creating in-store micro factory where the product can be made on demand. And this can enable them to make exactly what is wanted and when it's wanted. So it's reduced, waste, material and stock, cost of transport and cost of storage and shipping. And again, like the consequences of the carbon emission. So yeah, this is the exciting new step that I am looking into: production, market, how to deal with and how to work with other people in the industry.
Masa and Emily, what are next steps for you guys?
We're planning to continue with our process that we've used for our prototype in our next semester. So we're hoping to collect zebra and quagga mussels from each of the Great Lakes and then try the process, retest the cone program. So that's what we plan to do with our project, but I think one of the most beneficial parts of the process that we can take with us in our careers is learning to build connections with people that are outside of our field. And I think Biodesign Challenge really encouraged us to do that with meeting with scientists and ecologists and people that we normally wouldn't have crossed paths with, specifically in our field or even in an art school setting.
Great, thank you, Emily.
Mm-hmm.
Tessa, next steps for you guys. I mean, it's been a wild ride already.
Yeah, there's a lot of next steps, and I actually think Nancy brought up a really interesting point, which is, company growth, and, especially as we're thinking about, New York and where we want to establish ourselves for our larger facilities, both in labs, production, manufacturing, offices. This is really a massive focus for us, in the next 2 years, really making those strategic decisions on, where works best for us and how we can fit in there. So I think that's really a big focus, as well as with that, increasing our production. We really want everyone to be able to access our materials as soon as possible in order to have, the largest impact at the quickest rate. And so, we're really looking forward to that, looking forward to collaborating and growing our team.
Great. Well, I know we're about to go into the breakout rooms, but I just want to thank you all for spending the afternoon with us and talking about your experience and really sharing the journey with Biodesign Challenge. When we created the program, we really had no idea how it was going to work, what people would take away from it, whether the thesis of biodesign was something that the public had an appetite for. And I will say 5 years later, we are surprised and delighted every single year just to see what you guys are coming up with, to see the discipline grow. There is not one year that I don't think we've thought, oh my God, I would never have thought of that. And so it's just been an absolute pleasure. Thank you all. Thank you, Nancy, for inviting us to be on this call. It's been really wonderful.
I just want to add my thanks to all of you for your time this afternoon. And I know that our participants are anxious to meet some of you. So Carolina, can you take us into the chat rooms, please?